So once again, thank you everybody for joining us today. We've got a special guest today, Christian Karachi, who is a digital forensics expert. And before I hand over to him, I just wanted to do a bit of an introduction. So Christian has actually won awards in the past as the best speaker at the GSC. And I was asking him about some of his background. Where did he actually get started? So I've got a bit of an interesting introduction for him, actually. So Christian started in IT many years ago, and he was lucky enough to befriend one of the best criminal forensic prosecutors in the past, who became his mentor. And that brought his interest into forensics. And as he was working in IT, he was working on a project to recover some data. And on a workstation, he discovered that there was a keylogger software running on there. And he looked into it and he discovered that the operator was actually harvesting passwords on that workstation. So obviously there was some legal implications there and prosecutions, things like that. But that's when Christian discovered that the sniffing the ones and zeros of the digital world was far more attractive to him than smelling the fingerprints and blood spatters of physical forensics. Really.
That's correct.
Yeah.
They smell nicer.
Yeah, exactly. So Christian, he's learned to think like his prey, the malicious insider who preys on organizations and their vulnerabilities. And today he's going to be sharing with us some interesting insights about how criminals operate. And although he'll be careful not to give away too many secrets, it's going to be a very interesting session, really. And also, you never know, it might inspire some of you to follow in his footsteps. So with that, I'll hand over to Christian. And also, just please, any questions and comments you might have, please add that to the chat. And I'll read that out as we go along and towards the end of today's session as well. So with that, Christian, over to you.
Hello, everybody, wherever you are in the world. I know some of you across the phone woke up quite early or didn't go to sleep to attend this session. So thank you very much for attending. I hope you can hear me well. And welcome to Gun with the Bytes, the digital forensic saga. My objective today will be to give you some insights into data breach, define digital forensic science, define criminal behavior that leverages your weaknesses as a security professional, and to show you, to demonstrate you some criminal behavior. So a few insights into data breaching. The average total cost of a ransomware breach is $4.6 million. That's according to IBM. According to Verizon, 34% of data breaches involved internal actors. Now this raised to 40-something. I can't remember the latest number. The data breach life cycle of a malicious attack takes an average of 315 days. This is from since the attack begins until it is discovered. And more than 64% of financial service companies have 1,000 plus sensitive files accessible to every employee. This means your personal details, date of birth, full name, address, national insurance number, social security number if you're in the US or somewhere else in the world. Pet names, security, your security answers to the your answer to the security questions, and so on and so forth. Now let's see what is digital forensics. Digital forensics is the gathering and analysis of digital information in an authentic, accurate, and complete form for presentation as evidence in a civil proceeding or a court of law. This evidence, this digital evidence, can be developed from documents, from communications like email, instant messages, social media like Facebook, WhatsApp, Signal, Skype, Twitter, Telegram, so on and so forth. databases, and proprietary applications and or data. Criminal activities are, among criminal activities, we have identity theft, we have telecommunications fraud, such as cell phone abuse, online action fraud, like eBay or Amazon, trafficking in contraband, like child porn or selling of digital copyrighted content, network intrusions from external bad actors that result in resource damages. We have cyber threats, lately a lot of them, email harassment, ransomware, malware, you name it. And the reason why you're attending this session, and probably further ones that I will have along the line, pirating and loss of intellectual property. This is your very important and this is your very important data. Probably the research that you do in your company, a new piece of software, I don't know, a revolutionary something, airplane, vacuum cleaner, TV, you name it. Now, because this is the mainframe session, let's move into the mainframe world and describe a little bit of that systems environment. An IBM mainframe can process billions of transactions every day. It has many processors, huge amounts of memory and storage. And when I say huge, it is huge. Up to 40 terabytes of memory for each mainframe itself, up 5.9 petabyte storage capacity for a DASD or a VoLTE. A VoLTE or a DASD direct access. This storage is the equivalent of your PC or laptop hard disk. It also has enterprise-grade encryption, which means that it has a dedicated encryption chip. It has strict rules for accessing privileged information. That's the RACF database. It requires specialist knowledge to operate it, not your regular or usual computer, laptop or PC. It is deemed to be the most securable platform, not the most secure, but the most securable. But there is a plethora of tools available to decrypt and use the data stored on a mainframe with different off-host operating systems, like Windows, Linux, Mac OS, so on and so forth. These tools create an opportunity for exfiltration of confidential data. This exfiltration is unauthorized copying, transfer, or retrieval of data. The vulnerabilities are addressed through use of firewalls, company security policies, data loss prevention, ELP software, so on and so forth. But believe it or not, the bad actors had found different ways to go around these protections, and we'll talk about this in a few moments. Now, when it comes to insiders, the cybersecurity literature acknowledges 4 types, but they are pushing towards the following 3 of them. These are the inadvertent or the innocent one. This can be an employee or contractor who has access to data, to companies' confidential data, but they don't have any sort of security training or awareness, and therefore they make mistakes by not knowing, if you like. So they click that phishing link, or they respond to that email, and they open the attached document, which can be weaponized. We have the negligent one. This is again a contractor or an employee, but in this case, they do have security training and awareness. But being negligent, they totally disregard the company's security policy, and therefore they open up your company and your network to intrusion. And finally, we have the malicious. Now, like I said, the first two types are responsible mainly for third-party attacks, for hacks. I mean, they click that phishing link, or they give away their credentials to a third party, thinking it is they got phished, that they're contacted by help desk, IT help desk, or whatever, and they give away their credentials. And thus they open a door to an external bad actor into your organization. But the malicious one, oops, oh, okay, sorry, hang on, something happened here. Okay, so where were we? Hang on a second. This is Windows playing. I'll close this and I'll restart it. Give me 2 seconds.
Sure, no problem.
Yeah, well, sorry about that. I don't know what's going on here.
No, that's fine. That's fine.
Okay, so here we go. Like I said, the malicious one. It's an employee, contractor, or business partner who has or had access to an organization's network system or data. They can be a whistleblower, and probably the most notorious one is Edward Snowden. They can be a disgruntled employee, or they can be a job leaver. Also, financial or other burdens that can make them susceptible to blackmail. And they do cause intentional harm to your organization. Now, while this malicious actor, this malicious insider, they don't have to have advanced computer operating knowledge. I was in a situation where I investigated a breach, and the bad actor proved to be the regular Smith in that organization. But they were controlled by an extremely skilled bad actor. So the only thing that they did was to follow the bad actor's instructions using their credentials, and then they open up the organization to that insider. So I have to caution you that all data shown during these demos are fictitious. Any similarities with actual persons or organizations are only coincidental. Do not try to use bank or personal details shown. They are randomly generated and not real. Also, if you are trying the techniques presented, please make sure you know what you're doing. I had situations when some parties tried to blame me for breaking the laptop or the PC because they tried to use the technique that I presented, and obviously everything went wrong. That's not my fault. But anyway, please make sure you know what you are doing. Now, let's have a look at a few techniques that are used by insiders to exfiltrate your data. First, let's look a little bit at base64 encoding. Now, base64 encoding is around since like forever. It has been initially created when the first messages between computers appeared, or the first messages and emails appeared, because some of the interpreters they thought that the end of line or the new line code, which is 10, the binary 10, they interpret it as separate digits 1 and 0, and that's all sorts of funny things started to happen. So this is why basic support encoding is around that. It is also used as to encrypt digital certificates issued by different authorities. It is a very effective method of transmitting small amount of data using an HTML or XML file. What I mean by that is that inside such a file, one can embed base64 encoded information without affecting the functionality of the web page, of the respective page. Lately, it is also used to encode images that are embedded on websites because it saves a lot of space and a lot of bandwidth when the page loads up. The encrypted content is shown as by base64 delimiters and looks like normal HTML and encoding for the untrained eye. So now we will have a little bit of fun with this, and let me show you what I mean by base64 encoding. We have here, as you can see, booking.com, their website. I've downloaded it here. Let's run it a bit. Okay, I'll minimize this. Let's allow JavaScript as well. As you can see, the page is totally unaffected, so it works properly. The entire web page works as it should. I'm not interested in this at the moment. Images, everything is here. So if we are trying to find something, where are you going? Let's see, we're going to Cornwall on 16th, and we check out on 18th, and we search. Now we go online, obviously, and we have all the information here, all the available places to stay. Now, like I said, this page has embedded content into it. So if we open it, we edit it with Notepad++. This is your best friend in case you're wondering, as a security professional or as a programmer. This is a very effective tool. And we will find, let's say, base64, we will try to find. We find it here. As you can see, this is a really long block of text, which is base64 encoded, and goes on and on for quite a few screens. And oops, sorry, went too far. So we have here the end of the block delimiter. So let's see what this base64 encoding really is. And I saved it here. We copy this and we will decode it using an online decoder. Okay, again, we will set the to temporary trusted. We paste the content here and we decode it. It shouldn't be too long. As you can see, is an image. I don't know why it's not. Oh, yes, I know why it's not working as it should. So the image in question is this one. So this is the image that has been encoded. It's not working because unfortunately I have JavaScript blockers there. So, oh, there it was. There it was. Okay, it was opened up straight away. Okay, now another method exfiltrating data, stealing your precious information is steganography. Steganography is derived from the Greek word steganos, which means covered, concealed, or protected, and graphein, which means writing. So literally translated, it is hidden writing. Okay, this technique can be successfully applied to the large amounts of data without being detected by untrained eye. So what I mean by this is this. Let me share with you a short video. As you can see here, there is a link, but it's not visible. Even if you look, you have to look really close to notice that link there. It is what it's favorite. It's one of my favorite scenes from a film, which shows the importance of being professional in what you're doing. So let me share it with you.
You, there. What is your profession?
I'm a potter, sir.
And you, Arcadian, what is your profession?
Sculptor, sir.
You?
Blacksmith.
Spartans! What is your profession?
So, like I said, quite a few others out there and not too much professionals. Also, there is another way to do this, which I'll share it with you right now, and that is this. This is a regular Word document. Nothing gives it away in any way. Probably these spaces, but as we can see, it's in between pages. Now, if you have the curiosity to select last line of text, you can see it goes on, and also the character size disappear. Why? Because we have hidden text here. So let's do this. And we change the color of the text. And as you can see, the hidden text has been revealed. It is very easy to detect this, but I won't share with you online because the process is quite sensitive. So when you will join, if you will join my presentation on November, if I will present again, I will show you how this is achieved, and also more sophisticated techniques used by bad actors to steal your data. Okay, another very dangerous method is file embedding. It is dangerous because it allows one to leak huge amounts of data in apparently inoffensive files. So the technique consists of hiding one or more files into a smokescreen file with innocent content. The downside is that it requires advanced knowledge about properties of different file types. This applies to the bad actor, but to you as security professionals as well. So let's have another bit of fun here. And we will go here. Oops, that's empty. Okie dokie. Right. Let's move here. Oh, yes. Right. And have a little look at this. But firstly, let's have a look at this innocent Word document. So it's the same document I used in the previous demo. Nothing gives it away. Yes. Other than the size. It's 8.1 megabytes. And why is that? This is because it actually contains 4 databases. So let's move them up. Place them here. Right. We don't need this anymore. And let's see. First one. As you can see, it is a database containing personal information of some people. That includes telephone number, street address, email address, gender, date of birth, first and last name. Another one. Again, database. Again, I am repeating myself now. In the in-person session, I will show you how how you will find out this is a database and how you can find that there is hidden content into the file. So again, here we have a bunch of personal data for people who order cakes. Yeah. We have another one here. And this is a database containing client records. Again, salutation, first and last name, business. This time is also the business name. The address, full address, I mean, including email address, telephone number, and the date when the inquiry has been received. And the last one is again sort of a database containing personal information for the for the customers of a certain company. Now, there are some other techniques that obviously I won't share with you in a online presentation, which is recorded and then also on YouTube. Not because I don't trust you, but I don't trust the internet, and obviously I don't want to give somebody else's ideas. So let's see what are the key takeaways of this presentation. I gave you some insight into data breaches. I also gave you a glimpse into the digital forensic science and why it's important to your organization. I hope I gave you a little bit of an understanding of the criminal behavior, why some people are reacting or doing what they're doing. And please contact me if you feel I can help your organization. Now, are there any questions?
Thank you, Christian. That was really good. And I've got some key points I want to talk through in a second as well.
Yeah.
Things that I've learned today. But I have a question from Faisal.
Yeah.
What is your advice to avert us from clickbait? Do we left click and try to replicate what you're doing? If we do, is there any way we can delete our personal details afterwards?
I don't exactly quote that.
So with clickbait, for example,
Yeah.
I was to get an email from somebody saying,
Yeah.
so should we be tempted to click on it and try to then figure out what's going on, or should we just ignore it and delete the email, for example?
Well, the best practice, if you don't recognize the sender, you don't know the person, is to open it in a sandbox if you have one available. Otherwise, what you can do is if you're connected to a corporate network or something, unplug your network cable from behind your computer or laptop, and then open the email, because you never know. The attachment of the mail itself, the email itself, can be weaponized.
Okay, that makes sense. Okay, well, thanks for the question, Faisal, and thanks, Christian, for the response. So please, if anybody else has any questions, please do put them on the chat. But there's certain things I've observed today from your session that I like to kind of review. First of all, you mentioned the insider threat is high, and that's understandable because they have the credentials to access the sensitive data in the first place, especially when we're talking about the mainframe platform. The second point I noticed today is there's no need for any sophisticated tooling.
No, it's not. I mean, the only thing that is required is a skilled bad actor.
Yes.
You don't need complicated software. You can use the tools that are available with your operating system out of the box without absolutely any problem. Obviously, like I said, I will share this in a personal face-to-face meeting, not online.
Okay, appreciate that. Thank you. And also, you showed examples of images that hide data within them as well. So it seems like a very easy thing to do. So what we have to be able to do is to make sure that people haven't got access to sensitive data. But I'll talk more about that in a second. But the other thing, especially with your video that you played, it makes a good point, actually, which is that the professional forensics experts are really worth their value in gold, because I know every organization has a security team, and they don't see the breadth of data breaches that you might see. So the experience isn't there. So I know that you work a lot with organizations to, first of all, help them understand with these type of presentations, and I'm sure more scarier ones as well, to help them understand what the threats are so they can tighten up security on their mainframe with auditing, for example, and making sure they're on top of their security game as well with access of credentials, things like that.
I can give you an example here. a few years ago, I was involved in an incident. I investigated, obviously. I wasn't the victim of that incident. It's sort of a bit of funny story. So the organization, that organization, they thought at some point they might be breached. So what they've done, they've prepared a server, a spare server with all their applications and all their processes and everything, and set it aside, like an out-of-the-box solution, if you want.
Mhm.
On the same time, they were performing regular backups to their disaster recovery site of DRF. These backups happen on a certain day at a certain time. They had a disgruntled employee inside there who was quite high in the hierarchy of that company. So this disgruntled employee employed a hacker who wrote a logical bomb. A logical bomb is a piece of software, malware usually, that activates at a certain point in time. Then using his credentials, they pushed this logical bomb into the regular update, regular backup, that went to the DRF. Then the hacker stroked and blocked their server. What they've done immediately, they disconnected the server, they unplugged it from the network and from the power cable, throw it away, smashed it, put the new server on, the one that they already had prepared, power it on, and downloaded the last backup from the DRF. Obviously, that backup included the logical bomb. In less than an hour, they were back to square one.
Mm.
Now the problem is, by destroying the initial server, the server that has been initially attacked, they also destroyed any digital forensic artifacts that I should have been able to find there and help them further to chase this further, but it was too late, unfortunately. So yes, it is really important. It is really important that in every computer incident response team, you have a digital forensic examiner, or a digital forensic analyst, or something like that. Because what happens, although the main concern of your incident response team should be containment and eradication of that incident, it doesn't have to be done by any means. Because if you do it by any means, 9 cases out of 10, you will destroy important digital artifacts, and then you will find yourself in the not so fortunate position looking for evidence to present to the police or a court of law and being unable to find any.
Yeah, that's a very good point, actually. So the importance of preserving the actual crime scene is key. And I think, if I was to go back in time and restart my career, I would love to go into digital forensics because it is a fascinating field, definitely. So just looking at the chat again, so we don't have any more questions, but it looks like you've got a fan who might reach out to you afterwards and try to get you to book a ticket to Barbados for him from the application you went through today. So that might happen as a follow-up. But other than that, look, thank you so much. I know that you do offer a service where you can go in and help organizations review their policies and maybe share these kind of details with them as well. So if there's anybody in the audience who'd like to reach out to Christian afterwards, please feel free. And yes, the email address is at the bottom of that screen. And please do, I invite you to click on the link or the QR code and provide feedback for Christian. He's a regular attendee of the GSE events and a presenter, so I'm sure you'll see him in the November live event as well if you're attending that as well. So yeah, there appears to be no more questions or comments, Christian. So thank you so much
Thank you
for
very
preparing
much
for
for having
today.
me. Hope you enjoyed it.
Okay,
I also hope I will get the opportunity to present in November to the next conference, where obviously I will show you scarier content than this one.
fantastic.
Much scarier.
Okay, thanks again.
Thank you very much. Thank you.
All right, take care, and take care, everybody. Thanks for joining today.